Hello and welcome to this new section on algorithm selection and development in this course, Mastering Artificial Intelligence. So in this section, we'll help you learn how to do a couple of things like research, select and develop appropriate algorithm that can help you become a successful artificial intelligence engineer. And in this lecture onwards, we will start talking about how to research, select, and develop right machine learning algorithms or deep learning architectures based on the problem at hand and the available data. So, how do you think? How to research, select, and develop appropriate algorithm, whether it is a machine learning algorithm or deep learning architecture? So, how do you do that? It's based on, as we talked about, researching, selecting, and developing the right machine learning and deep learning algorithms and architectures are based on the problem that you have at hand and the data that you have available. And that involves many steps. And let's go through step by step. And there are a lot of lectures that you will find in this section. So first thing you need to do is to do the problem understanding and formulation. And there are three things that you need to do. First, understand the problem domain, objectives, and constraints. The second thing is you need to do is to define the problem as supervised, unsupervised, or reinforcement learning task. And third is to determine the type of output, whether it's a classification output, regression output, clustering output, and the evaluation matrix. Now, understanding the problem we have covered in detail in another section earlier to this. So I'm going to skip that and go straight to defining the problem as supervised, unsupervised, and reinforcement learning. So let's talk about how to define the problem that you have already understood and defined in terms of its domain, objective, and constraint. Now, is this a supervised, unsupervised, or reinforced learning task? How do you decide that? Any thoughts? So, define the problem as supervised, unsupervised, or reinforcement learning task depends on two factors: the nature of available data and the desired outcome. And how can you determine which type of reinforcement learning task is based on these two factors? Let's take a look at that. So let's take a look at where is supervised learning appropriate. In supervised learning, the data set consists of input-output pairs where each example in the data set is associated with a corresponding label or target value. And the goal is to learn a mapping from input to output based on the labeled training data, allowing the model to make prediction on unseen data. That's how it goes. And the examples of supervised learning tasks could be a classification, predicting discrete labels or categories, example spam detection, whether a particular mail or message is a spam or not a spam, sentiment analysis, neutral, positive, negative sentiment. Also, second is a class regression type where you predict continuous numerical values like house prices, stock prices, etc. And as we saw that it is entirely based on input-output data where input is known as well as for the training data, and then there is a corresponding label or target value. The second thing is unsupervised learning. In unsupervised learning, the data set consists of input data without corresponding labels or target values. So there is no output that is given in this unsupervised learning model. And here the goal is to find patterns, structures, or relationship within the data without explicit guidance from label examples. Now, what are the examples of unsupervised learning? Now, this could include clustering, where you group similar data points together into clusters based on their features like customer segmentation, image segmentation, and also you determine those labels finally. So, dimensionality reduction, reducing the number of features or variables while preserving the essential information of the data. Like principle, the couple of analysis that are using this dimensionality reduction is principal component analysis, t-distributed stochastic neighbor embedding. So these are some of the unsupervised learning tasks that you can use. The third one is the reinforcement learning, where the learning agent interacts with the environment and learns to take action to maximize cumulative rewards over a period of time, as you see. So there is input raw data, there is environment, and there is output, and there is an agent who gets rewarded based on the actions he takes. The agents receive feedback in the form of rewards or penalties based on his or her action, allowing it to learn optimal behavior through trials and error. Now, what are the examples of reinforcement learning tasks? Game playing, learning to play games such as chess or Go by maximizing score or winning probability. Robotics, training robots to perform tasks like navigation, manipulation, or control in simulated or real life environments. So to define the problem as supervised, unsupervised, and reinforcement learning, you need to ask few questions. And what are these questions? You need to ask three questions. And let's take one by one. The first question that you need to ask is, do you have labeled data with known outputs or target value? And if the answer is yes, then this is clearly a supervised learning task. If the answer is no, then you go ahead and ask the second question. Are you trying to find patterns or structure in unlabeled data? And if the answer there is yes, then what you do is very clearly it's a unsupervised learning task. And still the answer is no, then you ask the last question is, does the learning agent interpret with it, interact with the environment and receive feedback in the form of rewards? And if the answer is yes, then it is a reinforcement learning task that you have. So asking these questions in this order and sequence and eliminating or confirming the task is the way to go ahead and define the problem as supervised, unsupervised, or reinforcement learning task. So by answering these questions and understanding the characteristics of available data and desired outcomes, you can effectively define the problem as an appropriate type of learning task, as you saw. And having done that, what we do next? So having looked at the two steps, we will now talk about how to determine the type of output, whether it is a classification, regression, or clustering kind of output, and the associated evaluation matrices. That's what we will talk about in next few lectures as we go forward. So thank you so much for watching this first algorithm selection and development lecture in this course, Mastering Artificial Intelligence. I hope you continue to learn new things, continue to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download the PDF file to take a look at anything that you need.